we're going to talk about 3 different groups of numbers, but I want you to think about when you first started learning about numbers. How old do you think you were when you first started learning about numbers? Kindergarten? Anybody think they knew about numbers before kindergarten?
I do.
Yeah. Probably most of you could count before you went to kindergarten, right? And had some idea of number. Just basing it off of my own kids, because I have one son who's in kindergarten and one who's in preschool. And they're both pretty good at counting. They also have a math teacher for a mom, so that might have something to do with it. But they certainly had a pretty good understanding of number well before kindergarten. But they really only understand one number set. You guys know about a whole bunch of number sets, which I'm going to talk to you about today. But there's only one number set that I shouldn't say that. Probably 2 number sets that they have a pretty good understanding of. The first one is natural numbers. This is what you learn about when you're 2 or 3 or 4 years old. The set of natural numbers, and the symbol for that is a capital N, can be thought of as the counting numbers, 1, 2, 3, 4, 5, 6, and so on. The next set of numbers that you probably learned about after natural numbers are the whole numbers. And there's not much difference between the natural numbers and the whole numbers. Here's a definition for whole numbers. The whole numbers, which we use capital W to represent whole numbers, include all of the natural numbers plus one additional number, 0. So it's 0, 1, 2, 3, 4, 5, and so on. So actually, the whole numbers you probably learn about pretty quickly after you learn the natural numbers. You understand that concept of 0. After the whole numbers, things become a little bit more complicated, and some of them are ideas that you wouldn't really know about until you learned about them in school. For example, the integers. The integers include negative numbers, 0, and positive numbers, but still just those counting numbers, 1, 2, 3, 4, 5, and so on, and in the negatives, not things like 1.2 or something. They're positive and negative whole numbers are the integers. And those you probably didn't really talk about as a group of numbers until, I don't know, maybe about grade 6. The next set of numbers on your list there is the rational numbers. And these are actually, some of these are ones that you would have learned about when you were quite young, like fractions and that sort of thing. But the set of rational numbers, which we use a Q for rational numbers, includes all integers plus terminating and repeating decimals. These are any numbers that can be written as a fraction, a over b, where a and b are integers. So something like 1 over 2, 1/2, that's a rational number. But also just a number like 4, because that can be written as 4 over 1. Those are rational numbers. This is a big set of numbers. It includes all the natural numbers. It includes the whole numbers. It includes integers. But it also includes those decimal numbers. And fractions. So the last, well, not the last, but the next set of numbers here is irrational. And the symbol we use for that is Q with a bar over it to mean irrational. And those are non-terminating and non-repeating decimals. So if it's a decimal number that keeps going forever and doesn't have a repeated pattern, then it's irrational number. When we look at the rational numbers, I said it includes the integers, it includes the whole numbers, includes the rational numbers, but irrational numbers are completely separate from rational numbers. A number is either rational or irrational. It can't be both. It has to be one or the other, as long as it's a real number. Has to be either irrational or rational, but it can't be both. And then the last thing here that I'm going to show you is these real numbers, which we use a capital R to indicate a real number, and they include all the rational numbers and all the irrational numbers. So, well, almost all the numbers. There are also non-real or imaginary or complex numbers, but we don't get into that in high school. So basically, it's all of the numbers are the real numbers. This is a graphic organizer that can help you understand how the number sets all fit together. This whole box is all of the numbers. Well, it's all of the real numbers. So I'm just going to put real numbers there, and you might want to write the same thing. What's the symbol for real numbers? R. Capital R. So you could just write a capital R there if you want. So now we've established this is just numbers, and it's all the real numbers. But in here, there's kind of two distinct spots. There's this box down at the bottom, and then this one up at the top. And so we need two distinct sets of numbers for those two boxes. Do you know what they are?
Irrational numbers.
Irrational and rational. Those are kind of the two distinct sets that make up the real numbers. So I'll put irrational there and rational here. So inside the box is all the numbers, but inside this little box at the bottom, we're just going to put the irrational numbers. So those would be numbers like, can you think of any irrational numbers?
7.
Pi is an irrational number. The square root of 2 is an irrational number.
Both prime numbers.
Those are natural numbers. Prime numbers are natural numbers. Yep. Something like 0.12573, and I'm just going to put a dot, dot, dot after it to tell you that this keeps going with no pattern. That's what the dot, dot, dot means, is that decimal number keeps going with no pattern. That's an irrational number. So those kind of numbers go in there. Inside the rational numbers, we'd have numbers like 1/2 or 2 or -8. Those are rational numbers. But those are numbers that also fit into smaller subsets. So they're rational numbers, but inside the rational numbers, we have all these other subsets. We have integers. And two of those numbers that I wrote inside rational numbers are actually integers as well. Like the 2 and the -8 are integers.
Natural numbers are on the inside, right?
And natural numbers are right on the inside, yep. And whole numbers are next to that. So the smallest group of numbers is the natural numbers, although it's actually infinitely large, right?
So then why are we inside this box?
This box is like the universe. We're going to look at where do these numbers over here fit into this graphic organizer. So I just labeled them as real numbers, rational, integer, whole, and natural, and then irrational. That's what those different letters mean. And I want to put them in the innermost spot that it can go. So if I choose one of these numbers, let's choose -4, where would -4 fit? It's a real number, so I'm going to put it there, but I want to move it in as far as I can.
Oh, integers.
Integer, right. It's rational, for sure, but it's also integer, so it can keep moving in as far as integer.